How deep is the reproducibility crisis, and can open science help? A talk that I gave today at the University of Liverpool during Open Access Week, and it's an edited, snappier version of that talk. How open is the scientific process is our first question. The scientific process is very closed, so starting from the generation of ideas, the writing of research proposals, which are kept confidential, agency keeps it secret, ask reviewers to make the same promise, and eventually, if funded, a short summary is shared. Of course, if the grant is not funded, then the ideas remain in a drawer somewhere and eventually get lost. At the stage of experimentation, we do our research behind closed doors. We protect our results from competitors, both to have priority and to preserve eventual intellectual property. And then, at the level of dissemination, eventually sometimes the research is written in the form of articles, but not always, because sometimes the data are not good enough or whatever reason, and then this research is never shared. Articles are peer-reviewed, but the reports are confidential and never become publicly accessible, so that peers, academics who spend time doing some advanced work, doing some analysis, doing some thinking about their peers, about other people's work, and these analyses are, again, remain confidential and are not shared with the community. The articles themselves often are behind a paywall, and that's obviously the aim of open access is to freeing that very last step, but all the other steps also need more openness. So science is a chamber of secret. The data remained locked very often. If you want the data, you have to request it from the authors, and it can be a battle. A lot of the data never gets shared anyway, because it's negative data or it's messy data, and it's going to be difficult to be published in journals. The protocols are often not detailed enough to allow reproduction or reproducibility of the experiments, and then the peer review of the articles, as mentioned before, is remained also locked and is not shared. Scientific debates are absent from the literature, or not absent, but certainly a lot of problems with the literature, with specific articles that are known from a few scientists, but these discussions or these doubts remain at the level of private discussions in the hall of conferences, but are not available to all to participate and discuss. So, how deep is the reproducibility crisis? Seems pretty deep. And indeed, if we look, it's a bit scary. And what are we going to find at the bottom is probably not very nice either. Very deep, so reproducibility crisis is very deep, and it's partly related to this lack of openness. From this 2005 very well-known PLOS Medicine articles, which argued that most published research findings are false due to publication bias, due to more recent articles and their coverage in mainstream media, such as This Week argument that drug research is hampered by substandard animal testing procedures. We can see both the magnitude of the problem and also its impact on drug discovery, and also very recently on our understanding of ourselves, with the fact that many of the psychology results published are also not reproducible. We can also see from the top left Nature comment that that funding agencies are starting to notice and are starting to take actions, even though they are maybe too limited yet, actions to try to enhance reproducibility. So 2 short stories from my experience on attempts at correcting the scientific record and what I have learned from them. first one is stripy nanoparticles, which was deemed as a big tussle over tiny particles by one journalist, and this is the story very, very briefly, not going really over the science, but the question is related to the interpretation of these images and their interpretation as stripy nanoparticles. This was reported in the 2004 Nature Materials article, and I and a number of other people thought that this was simply an artifact from the technique used to acquire these images. The group who published the original work published several other articles on this same topic in the following years, and in 2009 we submitted a revisited paper challenging this body of work, first to Nature Materials and then to Small. This took 3 years to be published using this conventional, very slow publishing system, and so when it was finally published after 3 years, I started to blog about this controversy, and so you can find on my blog a lot of information about the story and various events related to this story. The point in the context of this talk is, what are the lessons that have been learned from this controversy? The first one is that correcting the scientific record is very, very slow. It's also very hard, and that most colleagues would rather stay quiet, that journals and universities are more interested in protecting their brand than the scientific record. But there are also some positive lessons, and these are about the fact that there are much better and faster ways to share information and to generate scientific discussion than waiting for a particular journal to go through an extremely slow process that eventually takes 3 years before discussion comes into the public domain. And so with this second story, which is just starting, so I'm not even going to discuss the science whatsoever, let's see if maybe we can find some help, and more specifically, if we can find, if the phenix can be open science in our case. This story is still ongoing, but the way we've decided to address the question of the smart flare, the controversy, or the possible way that these particles, which are supposed to detect mRNA inside cells, work, is through a completely open science project where we share in real time our experiments, our discoveries, our data, so that anyone can actually go there, check the data from themselves. We are also using a number of tools to express our analysis of the literature. So we use, for example, PubPeer to comment on the articles which have been published and making these comments available to everyone and allowing the authors to respond to these comments, although they have for the moment decided not to do so. We have published yesterday actually a preprint, so that took about 10 hours to get live on the preprint server, as opposed to 3 years for the revisited paper I mentioned before. We share our data both on a home data repository, which has a number of advantages, as well as on Figshare. And finally, we are shortly going to submit our paper on Science Open, where it will go live immediately, and peer review will happen after, so that everything is transparent and everyone can put their own comments on our article. So, is open science the phenix which will allow to solve the reproducibility crisis? I don't know yet. The future will tell us. Thank you very much.